Okay, right. Can you see the format, tude format? So I have given a topic, then history of the history of the atom and its content. So what is an atom? So like that, I have given some theory. Then I have then after I have left a space to write something. That's the nature. That's the way I have prepared your tude. Okay. So can you all see that every pages I have given some theories and I have left some spaces. Okay. So I will explain some theories and then I will give the things that I have left in your tude. Okay. So today, but today you haven't that paper. So tude. So I have to give each and every theories. Okay. So now today I have to give all the theories. Okay. So that's the right. Okay. Then from second day onward, you have your tude and theory book. So you can do your work with your theory book. Okay, right. So for the atomic structure, right? You know that atom is the smallest unit of matter. Okay, right. I'm sure everybody have heard that word, right? Atom is the simplest or the indivisible unit of matter, right? Early time, the scientists had two questions. One is, so matter can be divided infinitely or finitely, right? Matter can be divided finitely or infinitely. Okay. For that answer for that question, so one scientists was there, who is the John Dalton, who could say, no, the matter cannot be divided infinitely. The matter will end from the atom, right? Atom making නතර වෙනවා කියලා. That is the end point. That is the basic unit. That is the basic particle. So atom cannot be divided. Okay, then can't be divided. So at the same time, they have given for postulation. It is called Dalton's atomic theory. Okay, Dalton said that atom can't be divided further, and he said that another four postulation in his Dalton's atomic theory. Right. Today I am going to discuss the Dalton's atomic theory, and then after it was broken, so we will discuss what are the reasons, what are the reasons why they have broken. So basically the initial theory we have to give. I have to give. So what are the the postulations of Dalton's atomic theory and how they were broken. Okay. So Putang, right, right. Atom is the simplest or the smallest indivisible particle of matter. Okay, right. Can you all write with me some theory? Write atomic structure. Then can you write this one? What is an atom? What is an atom? What is an atom? What is an atom? Okay, right. You have to forget your tude, then theory book. So I will give in next week, before next week. So therefore today we have to write some theory. Okay, right here. What is an atom? Okay, atom is the atom is the atom is the smallest indivisible unit of matter. Unit of matter. Divisible unit of matter. Okay. Divisible units of matter. In 1808, 1808, John Dalton, in 1808, John Dalton, he's English scientist and a school teacher. He's an English scientist and a school teacher. School teacher formulated a precise definition of the of the of the indivisible building blocks of matter. Indivisible building blocks of matter. Indivisible building blocks of matter. We call atoms. Atoms. With the definition of his regarding atoms, he could give a theory regarding atoms and other atoms and their behaviors. Regarding atoms and their behaviors. Okay, he was able to give atomic theory regarding atoms and atomic behaviors and atomic natures. Okay, I'll finish. Regarding atoms and their behaviors. Okay, it is called Dalton's atomic theory. 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 Okay. Atomic theory. It consists with four postulations. It is consist with four postulations. consists with 4 phosphorylation. It is consisted with 4 phosphorylation. Okay. You see, it is consisted with 4 phosphorylation. Okay, so again I will explain what I am doing now. So in last time I conduct inauguration seminar for you. So at that time I have given my work plan and I have explained who I am. So then at that time I started a basic theory. So today I have started first unit. First unit atomic structure. Atomic structure mean, right, in this section, in this lesson and in this unit, we will discuss the nature of atom, behavior of atom, okay, nature of atom, behavior of atom, atomic models, and electron circulating around nucleus, and electron configuration, Puta, electron configuration. Then after we will discuss the periodic properties of periodic table, in periodic table. So the major thing we are discussing in this section is atoms and behavior of atom and atomic models. So initially, the term atom was proposed by John Dalton. He's a scientist and he's an English scientist and a school teacher. Okay, he was able to give a definition to an basic model of matter. He told that and he said that it is an atom, and with the definition of his regarding atom, he was able to give theory, Dalton's atomic theory. It is consisting with, consists with 4 phosphorylation. Okay, right? Can you all write down assumption of? Can you write assumptions of Dalton's atomic theory? Okay, assumptions of Dalton's atomic theory. Assumptions of Dalton's atomic theory. Okay, there are 4 assumptions. Okay, first I will give the 4 assumptions, then I will explain. Then in nowadays we all the 4 postulations have been broken. So then I will give why they have broken and what are the reasons for it. Okay, the first assumption and first postulation. Okay, first one. Can you write first assumption or first postulation in Dalton's atomic theory? Okay, then I will explain and I will give detail. First one. Okay, elements are made out of extremely small, extremely small, extremely small, indivisible, indivisible particles called atom. That is the first postulation. The smallest indivisible particle is called atoms. Okay, that is the first postulation in the Dalton's atomic theory. Right. I will explain the nature of it and how it was broken later. Okay, so the second postulation. First I will give all the 4 postulations. Okay, second postulation. All atoms of a given element, all atoms of a given element, all atoms of a given element are identical are identical in mass, identical in mass and size, are identical in mass and size, mass and size, mass and size. But the atom of one element are but the atom of one element are different from but the atom of one element are different from the atoms of different from the atoms of all other elements. Okay, atoms of the all other elements. Okay, he said that all atoms of or given elements are identical in mass and size, but another atoms of elements are different. Okay, that is the second postulation in Dalton's atomic theory, right? I will explain then after given the four postulation. Can you all write the third postulation? These are regarding atomic theory. Third postulation, right? He said that, right, like this one. Third postulation, can you all write? Atoms of one element, atoms of one element, atoms of one element cannot be changed. Atoms of one element cannot be changed into atom of a different element. cannot be changed into atom of a different element by chemical reactions by chemical reactions okay, by chemical reactions, right? If you can't write some specific note, please let me know. So I will provide whole the theory note for you. So sometime there can be a internet problem and reconnecting. So I will give the complete note. So if you miss a note, doesn't matter. You can write again from what the things you are hearing. So you start to write. කොහෙන් හරි තැනක් ඔයගලන්ට මිස් වුණොත් එතනින්ද ලියන්න පටන් ගන්න. කලින් මිස් වෙච්ච ටික අමතක يعني ඉඩ තියලා ලියන්න. මොකද මම complete note එක දෙන්න. That's the nature of the online, but I will try to keep this class as a physical class, not as online class. Okay, right? I will communicate with you. Okay, right? Did you write the third postulate completely or not? Right, I will read again. Atoms of one element cannot be changed into atoms of a different element by chemical reactions. So for the same sentence, atoms are neither created nor destroyed. Atoms are neither created nor destroyed in a chemical reaction. Atoms are neither created nor destroyed in a chemical reaction. Putha, I am on the Dalton's atomic theory. Right, this is just I have started this one. Right, you can understand clearly. Right, now already I have given three postulations. Then after I will go to first one and explain, and then second one, third and fourth one. Okay, So can you write the last and fourth postulation in Dalton's atomic theory? Right, anybody who miss a note, you can write from here onward. So I will provide complete note. So fourth one, a compound are formed by union of a compound are formed by union of two or more atoms of two or more atoms of different element atoms of different element in simple numerical ratio sometimes once you cannot understand, but I will explain all those things. Okay, now do you have anyone did miss the note? Okay, right. Put right, except right here. One thing you need to I need to say, you have decided, you have got a good and crucial decision in your life. What is that? You have decided to do your all A levels in English medium. Why? From grade 1 to grade 11, you can. So can you tell me the fourth and right? I will tell. Okay. Right. I will. Right. If you miss something, right, you can ask. Okay. I will repeat it. Okay. Fourth and last postulation, Puta. Compounds are formed. And also, Puta, I have video record. Okay. So I will give that. Compounds are formed by union of two or more atoms of different elements in a simple numerical ratio in a simple numerical ratio Okay, right. Okay, those are the four postulations. Okay, Puta. Here I will explain all the postulation in detail wise. Okay, right. The first postulation, he said that atoms are simple, indivisible unit of matter or particle of matter. Right? Can you all? Is it right? Is it correct in present days? Can you all give a message? Is it right? Is it correct? Is it right? Can you all send me a message? Is it right? Element? No. Why? Why? This is the way that we have to do in our all-level online class, because so when we communicate, right, you can go with it can further divide into subatomic particle. Yeah, it is correct. It is correct. In 1890 or 1880, the scientists were able to found some subatomic particle inside the atom, especially that electron, protons, and neutrons. Okay, therefore we are not considering this is true so far in present days. Okay, so because we have found some subatomic particle, electron, proton, neutrons, and another we have particles inside atom, neutrino, positron, so many particles are inside the atoms and nuclei. Okay, so we are not considered it as two further. Okay, and so far. Okay, so I will give a note then after. So what is the second postulation that Dalton's given? All atoms of a given element are identical in mass and size. All atoms of a given of given elements, okay, are identical in mass and size. Can you all tell me, is it a true postulation? Is it true? The atoms of a given elements are identical in mass and size. Is this correct or not? Huh? Is it correct or not? Is it true? Quickly. Huh? I know you know that you have heard all those things. Okay. Right. Anyone? කවුරු ඉන්නවද? ඒක හරිද වැරදිද? ඒක mass එකෙන් size එකෙන් identicalද? No. Right? Rishad, why is that? Why is no? Okay. All right. Puta, in nowadays, we have identified, yes, it is true, isotopes. Isotopes. Isotopes mean different species of an element, right? Different species of an element with same atomic number and different mass number. Okay, we have identified, we have recognized some isotopes, right? Like example, right? Hydrogen, we can consider 3 isotopes. Okay, one is protium, right? Protium, deuterium, and tritium. Protium, deuterium, and tritium. So protium, there are three isotopes. Isotopes තුනක් තියෙනවා. Right? Isotopes තුනක් තියෙනවා. What are them? Protium. Right? How many protons are there in protiums, Puta? How many protons? Can you write? Can you pass me a message? Because that's the way. Okay, එහෙම වුණාම කම්මැලි නෑ ඔයගලන්ට. හැමෝම එනිසා මගෙත් එක්ක engage වෙන්න. හරිද? That's the better way to study and learn. Right? Then after you will understand, right? We have spent, or we have done almost 2 hours, but you didn't feel, right? Protium has one proton and how many neutrons, Puta? And how many neutrons in protium? How many neutrons in protium? 0. Yeah, good. 0. How many proton in deuterium, Puta? How many proton in deuterium, Puta? 1. How many neutron in deuterium? How many neutrons? 1. Good. How many proton in tritium? How many yeah, good. How many neutron in tritium? Nice. Good. Right? Clever students, no? Here. Puta, you know that the heaviest subatomic particle of an atom. Okay, do you know that? What is the heaviest subatomic particle of atom? What is it? Do you know anyone? But I'm sure I have started new classes for institute, but no one given answer for it. කවුරුත් උත්තර දුන්නේ නැහැ. කවුරුත් උත්තර දුන්නේ නැහැ ඒකට. Yes. How do you know that? No. Shaman, no, no, Rajindu. One time answer. One time. Right? Don't go another answer. Right? Anyone else? One person given a correct answer. Anyone else? No? But the heaviest subatomic particle in atom is neutron. Neutrons and protons are approximately equal masses are there. But neutron is bit heavier than proton. Okay, approximately equal masses, but bit higher than proton. Okay, so you know that in isotopes, 0 proton neutron, 1 neutron and 2 neutrons. It means the masses from protium to tritium will increase, not as same. So you know that this is an element. It has three isotopes with different masses. So we cannot accept that second postulation so far. Okay, අපිට මේක තවදුරටත් පිළිගන්න බෑ. එයාගේ second postulation එක because we have found some isotopes in nature. So isotopes mean element with a different thundering, okay? Thundering and lightning and thundering. But doesn't matter, right? We'll do. Right here. ඔකුණු ගහනවා. මේ කමන්නේ. Right? This is very first day, no? Right here. Okay. Now the second postulation also broken. So shall we write the theory, no? Then after I will give for the third one. So can you write this one? Can you write all four postulation in Dalton's atomic theory were broken in present days or have been broken in present days thundering. Okay. Right, can you write this one? First postulation, collapse of first postulation. Sorry, collapse of first postulation. Right, under that we can write a collapse of first postulation. Collapse of I don't know what to do, but අයියෙන් වහිනවා සහ තණ්ඩරයෙන් වෙනවා. බලන්න අපි කරගෙන යමුනේ. පුතා ඕගලන්ට වහින්නේ නැද්ද? ඔයාලට වහින්නේ නැද්ද පොඩ්ඩක් වහිනවද සහ මේ දාන බාන කොහෙටද ඕගලන්ට වහින්නේ කියලා? ඔයාලට වහිනවද? Not much. Okay, collapse of first postulation. So can you all write this one? And here, the first postulation was collapse. The first postulation was collapse, 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 collapse. COLLAPSED. Collapse. With the discovery of discovery of the electron, proton, and neutron. With the discovery of the electron, proton, and neutron. Okay, then in this lesson, in this section, we will discuss how that, you know, what should I have to do, because lightning. Okay, right. We'll do. Right. I will discuss in this lesson, in this section, how the electron was found and discovered, and a proton and also a neutron, and also everything we will discuss in later. Okay. The second one, collapse of second postulation. Collapse of second postulation. Pudha, wait, just a minute. Everybody should have to pass a message. For what? To WhatsApp. Everybody should have to pass a message. හැමෝම දැන් මට WhatsApp message එකක් දාන්න. Today participated කියලා. Right, you know my numbers, no? My number. Participated කියලා දැන් message එකක් දාන්න. Right, everybody should have to send to WhatsApp, not for the chat box. WhatsApp, then done. Me then done. හැමෝම දාන්න දැන්. Quickly. 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 Okay. Adesh. Radas. Okay. Right, Buddha. Here. Okay. Right. Collapse of second postulation. Second postulation. Okay. Okay, you know that second postulation mean, you know that all atoms of given elements are identical in mass and size, but it was broken when you discover in the isotopes of element. Okay, right here, right? Can you write this one? The second postulation collapse with the collapse with the collapse with the collapse with the discovery of isotopes of particular elements. Discovery of isotopes of particular elements. Okay, right. Particular element. Pruta, I have to give some details regarding that. Right. Did you write? Right. Isotopes are the different species of a given element. Isotopes are the different species of a given element with the same atomic number and different mass numbers. With the same atomic number and different mass numbers. Okay. Can you write this example? With a different atomic number and different mass number and as same atomic number. Right. Hydrogen has three isotopes. Example, hydrogen has three isotopes, and now you can write everything in my board. The board I have given clear detail wise diagram. Hydrogen, three isotopes, protium, deuterium, tritium. In protium, one proton, one zero neutron. Here like this. Here like this. Once you finish, let me know. Give a pass a message. Okay. Heavy rain, no? Don't know, in every night. Yeah. Okay. Right. Everybody understood everything that I have given today? Everybody understood? Right. Like this, every notes and every calculations I will do in our whole syllabus as this. Okay. Right. I have good work plan. Yeah, I have very good work plan, and if you can execute it, definitely you will be able to get A, and you can enter to your what you wish, what your faculty you wish. Right, definitely you can go there. Right. Here, third postulation. You know that third postulation means atoms are neither created nor destroyed in a chemical reaction. Is it the third postulation? Is it the third postulation? Atoms are neither created nor destroyed in a chemical reaction. Okay. Yeah. Puda, is it correct? මෙයා කියනවා මේ atoms අපිට කියනවා create කරන්න බෑලු. ඒ වගේම atom destroy කරන්නත් බෑලු. ඒ කියන්නේ යම් කිසි atoms ගානක් මේ ලෝකේ තියෙනවා. මේ ලෝකේ තියෙන atom ගාන එහෙම්මම තියෙනවා. ඒ වගේම ඒව විනාශ වෙන්නෙත් නෑ. ඒ වගේම right we cannot create a new atom. Is it true? It can be true. අපිට අලුත් දේවල් හදන්න බැරිද? They can only be bonded and converted. You mean atoms cannot be atoms neither created nor destroyed, no? You are on that postulation. Am I correct? ඒක හරි කියන මතයද ඉන්නේ? ඔයා කියන්නේ combination එකක් වෙන්න පුළුවන් but cannot be created or destroyed. Is it correct? Is it your opinion? But doesn't matter. Okay. You are great than others because the many of you are silent. When you other silence, right? You will better if you can give any answer. Okay. But Buddha, in nowadays we can create new atoms and also we can destroy existing atoms. අපිට මේ තියෙන ඒවා විනාශ කරන්නත් පුළුවන් ඒ වගේම හදන්නත් පුළුවන්. Have you heard the reaction like nuclear reactions? I'm sure you have heard that name of word. Nuclear reaction, have you heard? Raise your hand. Nuclear reactions. I don't need an example, but have you heard that word? Wale වචනේ අහලා තියෙනවද පුතා? Right. Right. Okay, good. Very good. Puta, in normal chemical reactions, the atoms neither created nor destroys. It is correct. In normal reaction, Puta, the two or more atoms will bind together to form a different molecule or different compound. But when you consider a nuclear reaction, where the nuclear reaction is happening, where the nuclear reactions are taking place, Buddha? Can you write where the nuclear reactions are taking place? Nuclear reactions? Very good. Nuclear stations. Yeah, is it the nucleus? No, nuclear reactions. Nucleus, atomic bomb. Yeah, it's also Buddha. And in atomic bomb also taking place a nuclear reaction. But I didn't get a proper answer from you. But sure, in nuclear station mean. What about the law of conversion of mass? No. Law of conversion of mass is still constant. It's still true. But yeah, I will give that. Law of mass conversion is still true. Okay. Right? It has not broken. But in nuclear reaction, radiosity, yeah, it's correct. Good, huh? I'm so happy because you are asking various questions and you are giving good answers. So I'm very happy. Okay? If you can, Puta, you know that now I have to say this statement. I'm proudly say that I have completed my first degree in the University of Colombo. It was molecular biology and biochemistry. I have followed 3 subjects in the university: chemistry, molecular biology and biochemistry. In the university, in my first degree, I was able to do a subject, a nuclear science in the nuclear science department, University of Colombo. Mama University of Colombo එකේ nuclear science department එකේ මම nuclear science subject එකක් follow කරා. It's not a, it's an optional subject. It's not a compulsory subject. But I have completed that because මට ඒක ඉගෙන ගන්න ඕනකම තිබුණා. So I did it. Then after while I am studying in the university, I have written this theory, this point I have given to you. I have written 6 books in chemistry, 6 books in chemistry in single medium, special single medium, not in English medium. Right, I have one book here. This is one books I have written. This is me, and this is brief introduction regarding me. Right, this is the ISBN number. This is my publication, Vikramasinghe publication. Okay, like this. I have written this 6 books while I am studying in the university. So then I was able to do, or I need to do high studies. So I registered for the Masters in Applied Organic Chemistry in the University of Colombo. So I have completed my master degree or MSc degree in Applied Organic Chemistry in the University of Colombo Faculty of Science. මම master එකක් කරලා තියෙනවා. මම මේක කිව්වේ right, I need to go through a one step in my education. It is the PhD. When a person who can go, their ultimate education step is a PhD. Okay, so one step, I left one step, so I will do that. So why I have told those things to you? මං ඇයි ඔව කිව්වේ? මං ඔව කිව්වේ chemistry එක ගැන මම සාමාන්‍යයෙන් ටිකක් ඉගෙනගෙන තියෙනවා, වැඩිපුර ටිකක් ඉගෙනගෙන තියෙනවා. ඒ නිසා මම හරි කැමති, if you have any question, doesn't matter, you can ask me. Okay, ඕන ප්‍රශ්නයක් අහන්න කියලා මං කියනවා. මං හිතනවා මට මේ ප්‍රශ්නෙට උත්තර දෙන්න පුළුවන් කියලා. මොකද මම first degree complete කරලා, second degree complete කරලා, පොත් 6ක් ලියලා, ඒ වගේම I am doing some classes in local students and also foreign students. In these days I am doing a class for the UK student. Okay, UK student, and I have done for class for the US student. Okay, right, via Zoom. I have those things I have done. So doesn't matter, don't think twice. If you have a problem, you can ask me. මට ඕන ප්‍රශ්නයක් ඔයා අහන්න කියලා මම යෝජනා කරනවා. ඒ ගැන කිසිම worry වෙන්න එපා. මම දැන් කියන්නම් අර mass conversion එක ගැනත් කියන්නම්. පුතා මම මේක කිව්වට පස්සේ අර මගේ මැසේජ් දාපු පුතා හරි දුව හරි මට කියන්න ඔයාලට මේක තේරුණාද කියලා. පුතා මේක තමයි nuclear reaction එක ස්වභාවය. I will give one example. You know that beryllium, atomic number 4, mass number 9. So it was exposed to an alpha ray. Alpha ray means 2 to 4. By combination of these two particles, it was converted into carbon 612 plus neutron 01. Okay, in left hand side, beryllium is there and also alpha ray is there. But you know that atomic number 4 and 2 altogether 6. Atomic number 4 and 6 4 and 2 altogether 6. Can you all check that in right hand side? 6 and 0 altogether 6. 4 and 2 6, 6 and 0 6. No, atomic number has been changed. Here, mass number 9 plus 4, 13. Here, 12 plus 1 is also 13. It means mass number does not change. So, mass number or atomic number has no any changes. So, mass conversion theory was not broken. Again, අපි මේ ස්කන්ධ සංස්ථිතිය කියන එක වෙනස් වෙලා නැහැ. But I'm telling you, this is beryllium, this is carbon, right? That postulation state that atoms are neither created. There is no carbon in left hand side, but one time they are on right hand side. But there was a beryllium on left and right, no beryllium on right hand side. But all the masses are always constant. Mass number equal, atomic number equal, but species has been changed. ඔයාලට තේරෙනවද මම කියපු එක? ඔයාද මම ඇහුවේ අර පියුමාල් ප්‍රවීර ඔයාද මම ඇහුවේ මේ right. Now did you understand? Okay. Pradha, still mass constant or conversion is still is a constant, but like these reactions, the species can be changed, but mass are remaining unchanged. Okay, right. So shall we move into that? So I'm so happy because I have a chance to explain further. That's what I need to do. So if you have any questions, doesn't matter, don't think twice, you can ask. Any questions in chemistry, right? Any question in chemistry, not in your family problem or not in your other problems, right? I'm not going to give answers for that, but I will give answer for what? I will give answers for what? For what? For chemistry. Okay? Not for what? I'm not going to give answers for what? No. I will give. If you have problem, if you have a doubt or problem, doesn't matter. You can ask, right? I will give a better solution because I have life experience. Okay, here. Can you write this one? Right, here. The third postulation collapses with the third postulation collapses with the third postulation collapses with the finding of nuclear reactions. Finding of nuclear reaction. Finding of nuclear reaction. Okay, right. Consider the following nuclear reaction. Right here. Consider the following nuclear reaction. And write this one, then I will explain. මේක ලියා ගන්න පුතා හැමෝම මම ඊට පස්සේ මේක ගැන පැහැදිලි කිරීමක් කරන්න. මම මේ තා පොඩි දෙයක් ඔයගම ලියන ගාම අහගෙන මට උත්තර දෙන්න. ඔයගලන්ට මම පැහැදිලි කරන එක තවදුරටත් يعني සිංහලෙන් තව පැහැදිලි කිරීම කරන්න ඕන නම් චුට්ටක් මට මෙසේජ් එකක් දාන්න. ඒකේ මට ප්‍රශ්නයක් නැහැ. මට සිංහලෙන් ඉංග්‍රීසියෙන් දෙකෙන්ම කරන්න පුළුවන්. එතකොට ඔයගලන්ට තවත් අර ඉංග්‍රීසි ප්‍රමාණය අඩු කරලා සිංහලෙන් පැහැදිලි කරන්න ඕන නම් පුතා කියන්න. මොකද වැදගත් වෙන්නේ අපි මේක ඉංග්‍රීසි වලින් ටර්ම්ස් හදාගෙන අනේක මිසක් ඒ කියන්නේ සමහර ළමයි මම දන්නවා ඒ කියන්නේ අපි ඉංග්‍රීසි වලින් සිංහලෙන් උත් කරනවා වඩා හොඳයි වගේ පොඩි එහෙම එකක තියෙනවා. එහෙම ඉන්නම් කියන්නේ. ඒක ලැජ්ජ වෙන්න එපා ඒක. මොකද මම මම ඇත්තටම කැම්පස් එකේදී මගේ first 2 years I was faced a very big problem because lack of English understanding ability. හරිද? ඒක තමයි ලොකුම තිබිච්ච issue එක. first මම යුනිවර්සිටි එකේදී කොහොම හරි තියා වැඩ කළා ඊට පස්සේ ඉංග්‍රීසි හදාගෙන degree complete කරලා master complete කරලා ඉන්නේ. හරි. Once you finish let me know. Right? මට private message එකක් දාන්න මම එහෙම කරන්න ඕන කියන්න. Are there anyone who didn't give a message to me like as your participation? Okay, Pradha, once you finish, let me know. Did you finish? Pradha, did you finish? Huh? Still you are writing? Hello, can you hear me? Okay, right. According to the above nuclear reaction, according to the above nuclear reaction, according to the above nuclear reaction, beryllium was destroyed and beryllium was destroyed and oh beryllium destroyed and new carbon atom has been created. New carbon atom has been created. New carbon atom has been created. Therefore, new atom can be formed or new atom can be created. New atom can be formed or create, and new atom can be created, and existing atom can be destroyed. Existing atom can be destroyed. Okay. Right. Shall I erase these things? Okay, here. Right. Fourth postulation. Fourth postulation, Puta. Fourth postulation. Right. Fourth postulation mean two or more atom, the union of two or more atom, compound can be formed by union of two or more atoms, but they are combining in simple numerical ratios. Is it correct, Pudha? Right? What do you think? Is it correct? Right? All the compound, when you consider, when you search in all the compound, can you observe that kind of limit? Can you all observe that? Simple numerical ratio. Is it correct? Is it correct, Pudha? No. There are a few examples, or there are some example with the same with the theory, but like this right here. When you consider carbon dioxide, carbon to oxygen is 1 to 2. It's a simple numerical ratio. So when you consider ammonia, N2O, N2H is a 1 to 3 is a simple numerical ratio. Okay. When you consider sodium carbonate, Na2CO3, Na2C2O, 2 to 1 to 3. Here 2, 1, 3, 1, 3, 1, 2. But in present days, we have found so many various compound with the different ratios, like not simple numerical ratios. I'm sure you have studied about alkane in your O level. Have you studied? Have you studied alkanes in your O levels? Yes. Tell me, do you know the kind of alkanes, or do you know the basic formula of alkanes? Do you know basic formulas? But yes, very good and clever, nice. CnH2n plus 2. Anybody else? Do you remember? Do you remember? CnH2n plus 2? Yes. Here, when you consider CnH2n plus 2, so if n equal 5, you know that C5, H 10 plus 2, 12. 12. So C to H, 5 to 12. Can you tell me, is it a simple numerical ratio? Tell me, Puta. Is it a simple numerical ratio? No. No. There are various other compound in nature, but all the compounds are not in simple numerical ratios. A few examples are there, but Dalton said all the compounds have been formed in simple numerical ratios, but in nowadays we cannot accept that theory. Okay, right. Can you write? We have another examples also. Here, collapse of fourth phosphorylation. Fourth phosphorylation. Right. Fourth phosphorylation collapse with the fourth phosphorylation collapse with the fourth phosphorylation collapse with the finding new compounds, which are not satisfied, simple numerical ratios. Simple numerical ratios. Okay, right. Can you write an example like C5H12? Yes. I don't know whether I will say that same word, but I can repeat that. I have said that fourth phosphorylation collapse with the finding with the finding a molecule which has which are not satisfied, yeah, which are not satisfied simple numerical ratios, simple numerical ratio, which are not satisfied simple numerical ratio. Okay, now it's clear. Okay, Buddha. Right. Okay. Right. Can you write this one? C5H12 equals C2H 5 to 12. Okay. Right, Buddha. Right here. Right. Now I have given all the four positive relations, and now we are not considered all those things are true, but all the theories I have given. Uh, uh, everybody have understood all those things? Hello? Everybody understood? Raise your hand. And okay, how was it? How was it? කොහමද ඒ ටික තේරුණා හොඳටම? හරි. Okay. Right. So now I am going to find in an electron, proton, and neutrons in an atom. Okay, which means the finding subatomic particle of atom. Okay, right. Now, because the it was the reason to collapse first stimulation, right? There are so many scientists that were participated to finding electrons, protons, and neutrons, and there are so many experimental evidence, right? ගොඩාක් පරීක්ෂණ තියෙනවා. ඒ පරීක්ෂණ ටික මම කතා කරන්න යන්නේ. දැන් මම ඇවිල්ලා තියෙන්නේ වඩාත්ම වැදගත්, ඒ වගේම important, ඒ වගේම ඕගොල්ලන්ට කිසිම ක්ලාස් එකක බලා ගන්න බැරි තැනකට මම ඇවිල්ලා ඉන්නවා. මම ඒක තව පොඩ්ඩකින් පෙන්නනවා. ඒ කියන්නේ කිසිම ක්ලාස් එකක් cathode ray tube එකක් පෙන්වන්නේ නැහැ. But I will show in few minutes. Okay, right. Okay, can you write that the topic finding subatomic particles? Finding subatomic particles. Finding subatomic particles. Subatomic particles. Finding subatomic particles. Right. Okay, finish. Finish. Right. Finding an electron. Finding. ලියා ගන්න මෙහෙම ඊගාවට finding an electron. Finding an electron. Right. Finding an electron. Tuta, you know that the first postulation was collapsed by finding subatomic particle. The firstly or initially discovered subatomic particle is electron. Okay, electron. So it is found by, found by Sir J. Thomson. The practical was based on it is cathode ray experiment. හරිද? cathode ray experiment එක තමයි electron එක discover කරනකොට ඒගොල්ලෝ base කරගත්ත experiment එක. එතකොට ඒක සාමාන්‍යයෙන් හොයාගන්නේ පුතා, what is the name of the scientist I have mentioned? What is the scientist? So no, not what is the, who is the scientist? Who is the scientist? Sir J. Thomson. Right? Who is the? He is the training, right here. Okay. Before finding an electron, Puda, before finding an electron, there was a person, there was a scientist who given a name for electron. Okay? How is that? කොහොමද ඒක වෙන්නේ? scientist කෙනෙක් හිටියා. එයාගේ නම Johnston Stoney. Johnston Stoney said that there should be a particle to with respect to for us that current generate. So when you consider current, okay, a current generated by a small particle is called an electron. But at that time, right, there was no any person to discover a electron. How electron හොයාගෙන තිබුණේ නැහැ. හැබැයි ජොන්සන් ස්ටෝනි කියනවා electron කියලා එකක් තියෙන්න ඕන. ඒක තමයි current එකට response එක respective වෙන්නේ කියලා. ඒ කියන්නේ current එක ඇති කරන්නේ electron වලින්. එයා කියනවා current එක කියලා දෙයක් තියෙනවනේ. current එක මෙතන මෙතෙන්ට යනවනේ. ඒ යන්නේ ඒ වගේම current එක ඇති කරන්නේ okay fundamental particle එකක් මගේ. That fundamental particle is named as electron. Who was named? Johnston Stoney. But he was unable to find that. Right? There was no any evidence. But he could give a assumption or something. එයා කියනවා electron කියලා එකක් තියෙන්න ඕන. ඒ electron තමයි electricity එක generate කරන්න කියලා. හරිද? හැබැයි එයාට එහෙම evidence තිබුණේ නැහැ. එයාට practical evidence තිබුණේ නැහැ. ඒ නිසා එයාට ඒක හොයාගන්න බැරි වුණා. හැබැයි එයා කියනවා current එක ඇති කරන්නේත් current එක ගමන් කරන්නේත් මොනවා හරි fundamental unit එකකින් කියලා. fundamental particle එකකින් කියලා. ඒ fundamental particle එකට යා නමක් තියෙනවා electron එක කියලා. හැබැයි ඊට ගොඩ කාලෙට පස්සේ තමයි Sir J. Thomson පුතා හොයාගන්නේ electron එක cathode ray experiment එක මගින්. ඒ කියන්නේ initially he was able to give the name, right? Johnston Stoney. Okay, right, finding an electron, no? Right, can you all write this note? Right. Johnston G. Stoney. Johnston mean John NS Right. G. Stoney. Johnston G. Stoney. Johnston G. Stoney. Name the fundamental. Name the fundamental unit carrying. Unit carrying. Unit carrying. Electricity. Unit carrying. Electricity. Electricity. Can you change your pen? Can you take a different color code? වෙන පාට පැනක් ගන්න පුතේ. Carrying electricity as electrons. As electrons. Electrons. In 1891. 1891. You know that Dalton's atomic theory was proposed in 1808. 1808. Okay. But now 1891. But did not have any experimental evidence. But did not have any experimental evidence. But did not have any experimental evidence of its existence. Of its existence. Did not have any experimental evidence of its existence. Of its existence. Okay. During the mid 18,000 or during the mid 18,000. Okay. Thousands. Scientists began to study. Scientists began to study. Scientists began to study. Scientists began to study. Begins to study electrical began to study electrical discharge through. Began to study electrical discharge through a electrical discharge through a glass tube. Glass tube. Glass tube. Glass tube. Pump almost empty of air. Pump glass tube. Pump almost empty of air. Empty of air. This heavy raining, Buddha. Okay. This device was an invention of the. This device was an invention of the. Invention of the. Of the British chemist and physicist or physicist. British chemist and physicist. British chemist and physicist Sir William Crookes. Sir William Crookes. Sir William Crookes. Sir William Crookes. Crookes mean pata? Crookes, huh? Sir William Crookes. Crookes. Sir William Crookes. N is, I will explain, okay? N is called Crookes tube or Crookes tube or Crookes tubes or cathode ray tube. Crookes tube or cathode ray tube. Crookes tube or cathode ray tube. Okay. Okay, පුතා? Right. මෙහෙමයි. ප්‍රතිම ස්ටෝනි කියනවා ඉලෙක්ට්‍රන් එක තියෙනවා කියලා. But he was unable to find the electron by using any experiment. But a British scientist called William Crookes designed an experiment. අර යා experiment එක design කරාපතේ ඒකට කිව්වා cathode ray tube එක කියලා. ඒ cathode ray tube එකෙන් එයා හොයාගන්නවා unknown particle එකක්. එහෙම නැත්නම් කියනවා unknown rays ටිකක්. ඒ unknown rays ටික ඒගොල්ලන්ගේ properties investigate කරාම properties check කරාම එයාට හොයාගන්න ලැබුණා මේකේ මොනවද තියෙන්නේ කියලා. අවසානයේ හොයාගන්නවා මේකේ තියෙනවා ඉලෙක්ට්‍රෝන කියලා. got it? හරිද? මේකේ තියෙනවා ඉලෙක්ට්‍රෝන කියලා. එතකොට දැන් මොකද්ද මේ Crookes tube එක කියලා කියන්නේ? I will draw a Crookes tube and then after I will show. මෙන්න මේ වගේ tube එකක්. තමයි ඔය Crookes tube එක. Have you all there? ආගෙන නෙදින්නේ? නිදි නෑ නේද? මට නම් මේ ගොඩක් වහිනවා මම ඒත් වැඩේ කරන් යනවා. මොකද මම මේ online class පුතා shall we stop today's lesson because it's heavy raining. ගොඩක් හයියෙන් බහිනවා. ඒ වගේම එළිය ගොඩක් අකුණු ගහනවා. එළිය ගොඩක් අකුණු ගහනවා. සාමාන්‍යයෙන් normally මම 2 or 2.5 hours කරනවා. ඔයාට මම දැන් මට පෙන්වන්න පුළුවන් එළිය ගොඩක් වහිනවා පුතේ. මම දැන් ගොඩාක් වෙලා බලන් හිටියා මේ අකුණු ගහන මේ දැන් මම හයියෙන් කතා කරන්නේත් ඒකයි. ටිකක් කලින්ට මම ලවුඩ් කරලා කතා කරන්නේත් ඒකයි මේ ගොඩාක් හයියෙන් මම ඇහෙනවද දන්නේ නැහැ ඒගොල්ලන්ට ඒ සද්දේ. මොකද මම මේ ලැප් එක ප්ලග් කරලා තියෙන්නේ. ඒකේ බැටරි එක මේ යන්නේ නැහැ. මම ඔයාලට මේ කියන්නේ. ඒතර මේ අකුණු ගහන එක පොඩ්ඩක් dangerous වෙනවා. So I may stop class. So දැන් ඔයගොල්ලෝ හැමෝම මට ඔයගොල්ලන්ගේ ඇඩ්‍රස් එවන්න. හෙට මම ඔයගොල්ලන්ට ටියුට් එක කුරියර් කරනවා. එතකොට මේ අහන්න. මේක අහන්න. next day එක Sunday නෙවෙයි. ඉතින් Sunday කියන්නේ අවුරුදුනේ. මම ඒ නිසා ඔයගොල්ලන්ට ලබන සතියේ Thursday extra class එකක් arrange කරනවා. අහුණද හැමෝටම? extra class එකක් arrange කරනවා next මේ එන coming week එකේ Thursday රෑ 7ට. හැමෝටම ඇහුණද ඒක? හරි. එතකොට Thursday වෙන්න කලින් මම ඔයගොල්ලන් ටියුට් එක ගෙදරට කුරියර් කරනවා පුතේ. දැන් ක්ලාස් එකෙන් ලීව් වෙනාට පස්සේ මට ඔයගොල්ලන්ගේ ඇඩ්‍රස් ටික දැම්ම එවන්න. හරිද? මම දැන් වැඩිලා කතා කරන්නේ නැහැ මේ හදිස්සියෙන් ලොකු අකුණක් ගැහුවොත් ප්‍රශ්නයක් කරන්න පුතේ. ඒ නිසා මම දැන් නවත්තන්නම්. හැමෝම ඇඩ්‍රස් මට එවන්න. මේ Thursday රෑ 4 ලෑස්ති වෙන මැසේජ් උත් මම දාන්නම්. Okay? Good night to all of you and thank you for coming. Okay? Good night. sorry for the late ending class. Okay,